Hi everyone, we are going to use this small building to construct a 2-point perspective. We are not going to use all these drawings, we need them for these measurements and the height of the elements. But the only drawing that we are going to redraw, or if you have a printer you can print it out, is this drawing. And when you are drawing it or tracing over your screen, or if you are printing it, just make sure the scale is 1:100. Hopefully you can see that. So, okay, let's get started. We got this plan. We need to, the first step we need to do, we need to introduce a station point, so that where we are standing and looking at the building. So as we said in the session, imagine that cone of vision and how wide you are looking at the building. If you go very close to the building, then you get a very unusual or unnatural view as you're standing here. The perspective will be very skewed, and if you're standing there, I mean further away but to one direction, then you are going to see pretty much a similar view as an elevation. So what we want to do, we want to see both these sides. So we are going to stand somewhere here so we can see both these two sides of the building, as opposed to standing here or there. So we are standing somewhere here. We are going to stand slightly away from the building so we get that natural view. We thought maybe around 45 degrees is a good angle to look at the building. 50, 55, 60, that should be fine as well, more or less. Again, as we always say, there is no only one right way of doing it. But what I'm going to do, I'm going to maybe stand here so that I can see this side and this side of the building. And if I look at it, it's just roughly about 48, I would say, slightly wider than 45 degree. So if I choose this one as my station point, I'm going to call it a station point. This is the first step that we always take, and it's a very important step because it gives you that view, which sometimes when you do a 2-point perspective and you go back to it and you're like, probably is not the view that I wanted, it's too close or too wide. Then you go back and you change your station point and you get a different view. So it's more of a trial and error sometimes to get exactly the view that you want. But for this exercise, we are going just to choose this for now. And this is the first step. The second step would be, I'm going to draw lines, dotted lines, from either side so that I can see that wide angle that I'm looking at. So this angle we said is around about 50 degrees, 48-ish. Next, I want to draw a center line to indicate the center line of vision. So if I draw that here perhaps, so this is my center line of vision. So let's call it center line of vision. Okay, center line of vision, and this is the angle that we're looking at, which is roughly about 48, I would say, slightly more than 45. So this is the first step. The second step, what we want to do, we want to rotate this plan so that the center line of vision is perpendicular to our parallel motion here. So that, or if you don't have a drawing board, is parallel to the edge of your paper or your desk. So we want to rotate these so that this angle is 90 degrees. And I'm going to grab a detail paper. Try to use an A3 so that you have enough room. So as you can see, I can see through that paper, and that's what hopefully you'll be able to see at home. But because I'm recording this and I'm using this camera, which is not the best, what I'm going to do, I'm going to trace over these as an extra step for me. You don't need to do that because you can see it already there. Or if you don't have a printer, then if you want to trace over the drawing, then you can probably do that on this paper, on an A3 paper. But the only thing is that when you rotate it, you want to make sure the center line of vision is perpendicular to your parallel motion, as it is here. So if I was just to quickly trace over this drawing or the plan, just so that you can see better. You don't need to do that, it's an extra step, but as I said, I think it would be helpful to you. And this is the center line of vision. So what we've got here, we could probably actually take that off. So that's the window there. I'm going just to take this one and so we have traced over this so that you can see that better. Okay, now that we have got a center line of vision perpendicular to our parallel motion, so that makes it easier. The next step is to draw the picture plane, and the picture plane, similar to station point, can be anywhere really, but because I don't have enough space, and I think that putting a picture plane not so far from the plan here somewhere would give me a reasonably good view. So I'm going to take maybe 10 millimeters, so 1 centimeters from the edge of my plan, and I'm going to draw this line, which I'm going to call it the picture plane. Okay, the next thing we want to do, we want to draw our ground line and eye line. Maybe let's go for 4.5, maybe here somewhere for our, this is the eye line or horizon, and from the horizon we get 1.8, and this is our ground line. So let's draw these ones. Okay, what we've got the picture plane, we've got the ground line, so the ground level 0. Let me just write it here so that you can see ground line and eye line. It's here, eye line. Okay, so these are the three that we need, and again, as you move the picture plane, that would give you a different view. If you move the eye line, if a person is taller, or if you're looking at it maybe at a bird's eye view, then that would be quite higher. So if I was just to kind of demonstrate, if you're standing and looking at the building here, as you move your station point, that would give you a different view. If you move the person's view here or there, that would give you a different view as well. And if you move the picture plane closer or further away from the building, that would give you a different view. Just want to say that all of these are correct, but depending on where you put these, it gives you a better or a maybe less natural or more natural viewpoint. Therefore, if we are taking the average human eye level height, about 1.8, and then if we leave the picture plane here for two reasons. The first reason being I'm using this camera, and the second reason, I think that would give us a good view. But you can do a couple of sketches before you commit to your picture plane and ground line. So this step 1 was station point, center line of vision. Let's go all the way up, so we can call that. So this was the center line of vision, and we've got the eye level, ground line. So this is 0. This is the line. We've got the ground and the human eye 1.8 eye line or horizon line, and we've got the picture plane, which is not far away from the edge of this our plan here. I mean, you could move it and put it here, you could put it even here, you could put it further up there, all correct, but gives you a different perspectival view. Okay, next step, we are going to draw a height line, because we cannot trust our ruler for perspective drawing. Of course, this plan is 1 to 100, as you can see, but then we cannot measure using this ruler in our perspectival view. So what we need to do, we need to actually create a ruler, so where we can measure things and we can trust. So this method of creating a ruler for this particular drawing is where you take one side of the building, either side, we can do both even, and then you extend this line. So while you're standing there, you're looking at this two walls, yeah, or this view. It's not exactly, just to show you that we're looking at these two. So therefore, if I extend this so that it hits the picture plane, and then I draw a vertical line, and that is where it's useful to rotate the center line of vision, because I need to draw a parallel line here, so it makes it so easy. So this parallel line to center line of vision is the height line. So we call this one the height line. Yeah. Hopefully you can see that. I'm just going to move the camera slightly up. Okay, this is the height line. And either way, you could go this way. You could extend this wall, and that would give you a height line as well. So they are the same. So these two lines are the only place that we can trust to measure. So we cannot measure from here. or any part of these drawing, the only place we can trust our scale ruler or ruler is this. So we have created this method of measuring things proportional. Okay, so because I can trust this height line, it means the intersection between ground line and the height line is 0. Okay, so if we call this one 0 or plus minus 0, then we can go ahead and we can measure from this height line, as we said. So this is the only place we can measure. So this is 1000 millimeters, 2000, 3000 and 4000 millimeters. Okay, we can do the halves as well, so that we've got these measurements can come handy. So that would be 1000, 2 and 3000. I'm not going to put all of the marks, so that gives us some indications. And you could do that here as well. So these two are pretty much similar. Either way are correct. Either way, if you can trust these two as your ruler. And it was drawn by extending either side of the building that we're looking at. So one more step is to introduce 2 vanishing points, because we are drawing a 2-point perspective, which means we need 2 vanishing points. And when, again, I'm going to refer to this, when we are looking at this and we've got these 2 walls, if you like, these 2 sides of the building that we're looking at, one vanishing point would be there, and one vanishing point would be on the other side. So left and right, 2 vanishing points, and one will be parallel to this. So if I draw a line parallel to this side, just make sure you are drawing a parallel line. So a parallel line here, and another line parallel to the other side to hit the picture plane. So we are referring always to this plan, and we are using the picture plane to construct all these lines. So, and we know that always vanishing points are on the eye line or horizon line. So we take them up from the picture plane, and there we have our vanishing points. So this is vanishing point 1 and vanishing point 2, or left and right, as you wish. So important to establish vanishing points, important to establish height line. 1 should be enough. Important to establish these 3, eye line or horizon line, ground line and picture plane, and of course these things that we started off with. So now we can finally get to draw a 2-point perspective. So these are all these construction lines that helps us to draw an accurate 2-point perspective. It might get a bit confusing and difficult with the lines and you know, the geometrical sense of finding all these points, but once you do it and you follow all these instructions, it becomes sensible and easy for the next task. So just hope you're keeping up with me. So from this point we can actually start locating points from the plan and drawing them in a perspectival view. we know that this is 0, which is a good starting point. The intersection between height line, or ruler, and ground line is 0. And we know that from the 0, we go to vanishing point here. So we are going to extend this one for now. Just carry over this here. And now we need to find maybe one of these. So if we go A, B, and C, let's find these 3 points. So if we start with this point, so if you want to find any point from the plan, you draw a line from station point where you're standing, passing through that particular point and hitting the picture plane. Okay, I just extended this line to hit the picture plane, and then I go all the way up vertically, and the intersection between 0, because this point is where we are going to draw. We are finding this point. This is an axonometric view, but we are finding this point just to give you the idea. So if you're finding that point, it is on the ground, which means it is on the line indicating 0. So this line actually is the 0 going to the vanishing point 1. Okay, so this is point B in my perspective drawing, in my perspective view. But that point has a height to create this line, yeah? And that height is 3 meters, okay? So that was 0, and this is at 3 meters height. And we know 3 meters is there, okay? That was 0, and we are going to do the same from 3000 to converge to vanishing point 1. And here we've got the height of this. So if that was B, this is the height, this is B, maybe prime. So this is the height of this point. So if you've got that line, so this is the line that I've just drawn. And notice that all these lines, if I draw a few vertical lines, all these will be 3 meters height. That would represent 3 meters height. Even that represents, this small tiny line represents 3 meters height. Even that there represents 3 meters height. So all is the distance between these two, if you draw a vertical line, that would give you an indication of 3 meters high in perspectival view. So if you were to draw point A, which is there, we would do same. So any point you want to find from the plan, you draw a line from where you're standing, station point, and you pass through that to hit the picture plane. Okay, but imagine you're looking at this point, you're getting to the picture plane, and you are drawing that up, projecting that from the picture plane. And that line, the intersection of that line, you can go here, the intersection between this line and the 0 would give us point A. So that is point A, which is there, and this is located on this AB line. So I'm drawing this line in a perspective view, which is that, and if you look at that, this line and all these lines should converge to vanishing point 1, because this is this side. So all these, the lines that you've got on plan and are parallel to this vanishing point 1 converge to vanishing point 1. Okay, so and again, as we said, so between these two always 3 meters, and therefore the intersection is the height from point A on the ground. So I've got that here. So basically we've got these 4 points, which means we've got this wall drawn in perspective view. Okay. So now I want to draw these two. So I want to find point C, which is there, and the point C, again, we are going to repeat this the same. We are going from station point, pass through point C, hit the picture plane, draw a vertical line, and now we've got another 0 here, which means if we take from point A, if you want to draw this point, this wall AC, this AC wall, because it's parallel to this line, which converges to vanishing point 2, which means from A to vanishing point 2 should pass through 0 on our second height line, and that's how you test your drawing is correct. So if you draw a line from A to vanishing point 2, that should pass through 0, and that's how you check if your drawing is correct. And obviously from that point goes to vanishing point 2 as well, because we are drawing AC wall, and the AC converges to vanishing point 2. And we want to see all these construction lines, so do not get rid of these construction lines, but make sure you have these lines very faint. I had to put a bit more pressure so you can see that, but your construction lines, don't get rid of them, don't erase them, but have them very faint and nicely drawn. So again, all these lines between these two indicate 3 meters, and to find C, we are going to, as I said, go to picture plane, vertical line, and the intersection between these two that converges to vanishing point 2 gives us this wall, or this line in perspectival view. Okay, and AC is just, if we connect these two, so this is AC. I'm not gonna thicken up because I've got an arch here, but you could go ahead and thicken up this one. So this is the other side of the building. What we need to do now, we need to find the arch here, so this archway, and this window there as well. From here actually becomes quite easy, and the same technique applies for everything that you want to find on plan. So you always refer back to the plan. For instance, if you've got these 4 points here, let's call them 1, 2, 3, and 4. So we need to find these 4, and we are not going to see point 3, because you know you get to see 1, 2, and 4, but not 3, because that gets blocked unless it was transparent. But let's find 1 and 2 so that we know the location of these. Point 1, from station point to point 1, extend to hit the picture plane, vertical line, very faint line, and the intersection with the line indicating ground or indicating 0 is point 1. So point 2, pretty much the same, from station point to point 2, station point, point 2, extend that, hit the picture plane, vertical line, and so these two lines are actually these two. Okay, so these two are these two lines, and of course we know the intersection with the ground is 1 and 2, so 1 and 2. So we can actually thicken up the rest of it, because the opening is there. And now we need to find this point, because we have found this point, which is 1, and this point is 2 there, 1 and 2. Now we need to find the height of point 1 and the height of point 2, and also we need to find the arc here, and this is located in the center line, so it's the center of that, that's the center. Okay, what we need to do, we need to measure first. We need to get this measurement, which is 1800, so, and put it from our height line where we can trust. So that's the only place we can trust. So let's use a 1 to 100, say 1 meter and 800 falls exactly on the eye line, and the intersection is the height of point A. If it's not clear, just go back to and watch that again. So basically what I've found is this two. So if I connect these two, what I need to do now, I need to find this one and that. 2 is here, and we said the intersection with 1.8 would give us the height for point 2. And now what we need to find is somewhere here, we need to find this point. Let's call it 5.5 if you like. So what we are going to do, we need to find the center. So from the center, we go to station point center, hit the picture plane, go all the way up, and the point or 0.5 is located on that, somewhere on that. So what I've done, I've drawn this line, but I don't know where that point sits on this at the minute. What I need to do, I need to get that measurement, and that is 2.5, this should be 0, 2,500, okay, 2.5. So I'm going to measure 2.5 where I can trust. That's the only place I can trust. So 2.5, or you can use your scale ruler, same really, it's not that difficult. So 2.5 on 1 to 100, because that's where I can trust my ruler, the height lines. And from 2.5, everything goes to vanishing points, and this goes to vanishing point 2 because it's located on this wall, and the intersection between that middle line and the 2.5 indication of 2.5, that is 2500 as indicated here, is that 0.5. Okay, so if you could maybe do two segments rather than just one and be more accurate, but for me, for this exercise, I'm just gonna do the arc with 2 points. So just okay, and this is the other side, and that is the arc. So we know that we can see this thickness here, so we can see 0.4. So the 0.4 would be very much similar to the other, the same technique, from station point to 4, and then hit the picture plane, go all the way up, and this time there is one thing different. So 0.4 is not here. It can't be here, and the reason is I'm trying to draw 0.24, yeah, and this little small line is parallel to this line, meaning that from point 2 this line would converge to vanishing point 1, although it's the underside, but it's parallel to this to this line which vanishes to vanishing point 1. So from my point 2, which was here, I'll go a line, a very faint line, to vanishing point 1, and that intersection is 0.4. Okay, so that is 0.4. So the 0.4 wasn't there. Don't make that mistake to put it here, because I'm trying to draw the point. I'm trying to draw this line 2,4, which is parallel to that, converging to vanishing point 1. Therefore, from point 2, I have to draw a line converging to vanishing point 1. Therefore, that intersection is here, and that is 0.4. Okay, so if I go all the way up, that's coincidence that the 1.8 eye line is the same as 1.8 here, the arc. Sorry, this one. So the 1.8 falls exactly on this. So this, we've got that here, and we can again just quickly look at this bit that we get to see. Okay, and that is the thickness of that arc that we can see, and we can get rid of some of these lines, not all of them. They're nice, just leave them. And now we are going to do the window. Pretty much the same. Do 1, 2, 3, 4, and again we can't see 0.3, but we can see 1, 2, and 4. Same technique. 1, station point, passing through 1, hit the picture plane, go up, and point 1 is not, the window is not on the ground floor, so we can't mark this one. This is on the ground floor. Point 1 here on the window is located at 900 millimeters off the ground. So where we can trust our ruler is here. So this is 900. So if I was to draw a line from vanishing point 1 passing through that 900, that intersection gives me 0.1 here. Okay, so this is what I just drawn. point 1 there, and that point has a height. The height is 1500, we can see here. So from, or if we go 2.4 from the ground, we can measure that. 2.4 is there. So 1, 2, 2.4, and from 2.4 everything goes to vanishing point, and the intersection is the height of this 1.1. You can see that it feels that it's quite far away, but that's exactly the illusion of perspective, or the illusion of that perspectival view, that this line that I'm drawing, or this line, is there. But that is correct. That's the illusion that you get from that view. So if you change your position, you would get a different view. In order to find point 2, I'm going to repeat that. Station point, point 2, hit the picture plane, go all the way up, and that's the 900. That's the indication of 900 of the ground. This is 0, this is 900, this is 2.4. Yeah. And we've got that, which is exactly located on the correct place when we are standing here. Okay, so if I want to draw this 2, 4, this small line, you've got to be careful, because this point, this 2 to 4 travels in this direction, which means vanishes to vanishing point 2, or converges to vanishing point 2. So if I'm at point 2, which is there, I need to go to vanishing point 2 rather than 1, and the same here, vanishing point 2. Okay, and there we can go and find this point number 4, picture plane, and go all the way up, and that intersection gives me 0.4 and the height, so therefore the thickness of the window. So these are all accurate. So now the question is, if that's the windowsill there, and the windowsill is 3, 4, this line travels in this direction, yeah, is parallel to that direction, which means vanishes or converges to vanishing point 1, meaning that that needs to go this way this time. Okay, so now we've got this window with the thickness, and everything is accurate to the measurements, and that is the that's the difficult bit, and that is a different technique that we are using, and this is quite an interesting, geometrically it's quite interesting when you look at constructing a perspectival view. So I hope that actually you use it more and more in your studio, and it doesn't have to be very time consuming each time. You can do quick sketches, and then when you finalize it, then you can commit to it. So if you do a couple of sketches moving the station point, and then the view that you're more happy with, you can produce a very accurate drawing. So next thing we want to do, we want to draw this pitch roof and these elements on the roof, the chimneys. So what we're going to do, but one thing before I move to the roof is that when this one is, if that is open, you are going to see this line. So there is a line that you're going to see here. So if you say this is point C, obviously, and the point C to D, if you say D, CD travels in this direction, which means from C converges to vanishing point and that is kind of a dotted line because you're not going to see that. Yeah. And BD travels in this direction, which means vanishes or converges to vanishing point 2. Again, that is dotted line. And you can see that is the floor plan that we have just drawn. And if you want to go and draw the thickness of that wall, which we can see this wall here, we can again find that thickness. We can find this if I just extend that line so that I can draw this line in my perspective view. So if I find this point next to point C, it's there. Again, very faint. So that is the thickness that I have got. So from that thickness, because that line travels to this direction, it should go to vanishing point 1. And that is the thickness of my wall there. And that's the bit that I can see. The rest of it is dotted line. And if you really want to draw a thickness of that to show the floor plan, then that would be just to get the thickness of it. You can see that this is here, so, and that point travels, or this line travels in this direction, which means we can go to vanishing point 2. And we've got the thickness here, and this travels in this direction, meaning that converges to vanishing point 2, and the final one is this one, which converges to vanishing point 1. So that is the floor plan. So basically that is the floor plan in perspective view. I mean, you can go ahead and add details. Maybe you could go ahead and add the window there with the window sill and so on. The glass there. And so on. But let's finish off the roof and include these two chimneys as well. So if we give them, maybe mark them as M, K, N, and P, O, and Q, something like that, just to make it easier to explain. I need to find the height of it, the height of these on the pitch roof, and the height of it is 4,400 from there to there. So if we measure that 4,400 here, that is from 0, 4,400 is there. So if that measures 4,400, and I can trust this measurement, therefore if I go from there to vanishing point 2, and because that is located on this central line, so if I extend this central line, the intersection would be the 4.4 thousand millimeters off the ground that I'm looking for. And if I'm trying to draw this line at 4,400, then similar to the pitch roof, I'm going to go to vanishing point 1, and that is the height of the chimneys. Then we need to find these here. Let's find K. So if we go from K, from station point to K, and that is K, and hit the picture plane and go up, that intersection here is where the chimney, the first chimney, is located. And if you want to find M, same station point, passing through M, hitting the picture plane, going all the way up. And if you want to draw KM, KM is parallel to this, which means converges to vanishing point 2. The intersection is where the chimney or point M is located. And to find point N, we do the same. Station point N, extend it to hit the picture plane, go all the way up, and here is, we'll bring it slightly lower than the pitch roof. We'll use the vanishing point 1. By now you should know why sometimes we use vanishing point 1, sometimes we use vanishing point 2. And the answer, you know it. The line that are parallel to this go to vanishing point 1. For instance, Kn parallel to this converges to vanishing point 1, and so on. And if we connect these two, and that is the first chimney, the second chimney, pretty much the same, and it's located on this line. But if I want to find O, which is this point, I go from station point past the O mark and then go all the way up, and that is O here. P is there, going all the way up, and OP parallel to this goes to vanishing point 2, and the intersection is point P. And again, I'm going to use vanishing point 1 to draw the final lines Q, and go all the way up to mark the Q. So that is the second chimney. Let's connect these two, and that is it. I know it might sound a bit confusing, but you should be able to follow the steps and use the technique to do your studio project. But first, do this one, follow the instructions step by step, and then that should be it, really. So just what we are going to do, we are going to just tidy up these. We need the construction lines. Leave all the construction lines, please. Do not erase them. Maybe if you want to just make them a little bit faint, that's fine, but do not erase them. Maybe just going over some of these very lightly so that they are very faint, but we can see them still. If you want to go ahead and do some shading, you can do so. If you want to thicken up some of these lines, again, that could help. You could maybe shade a little bit to give it a bit of a depth. Okay, and maybe you want to go ahead and draw the using dotted line, we can draw some internal, maybe the internal ceiling. So that goes to vanishing point 2, and this goes to vanishing point 1, the intersection here. So we can draw that dotted line.